All right, algebraites. Let's attack, kill, destroy. What we want to do in this one is we are going to add or subtract rational expressions. And yesterday what we did was solve these ones or simplify these when they had a like denominator. So clearly 18 and 18. So all we had to do was combine the numerator. No big whoop. So, complicate things because that's the way we roll. What if we have different denominators? What the Gehenna are we going to do about that? Well, here's what we can do. The key is to find the lowest common denominator. In actual fact, that's a lie. It's not just the lowest common, it's any common denominator. But in finding the lowest or the least common denominator, there's less work for you to do later. Okay, so we need to find a common denominator. Now, generally speaking, many of us get confused about GCF versus LCM. Now, usually these are factors, which means they generally are smaller numbers, okay? I take a 12 and I split it up into a 6 and a 2, okay? So those are my factors. They're smaller than my original number, usually, because 12 times 1 is 12 is a factor also. Now, LCM gets larger, usually. Why? Because I'm counting by 12s now. I'm going up. It's a multiple. 1 times 12, 2 times 12, 3 times 12, etc. So an LCD is an LCM, just down below. All right, so how do we find the LCM here between 18 and 24? There's multiple ways. I'll walk through at least 2 different ways to do this. Number 1, back in elementary school, you may have been taught like this, where you just start counting, right? 18 times 1 is 18. 18 times 2 is 36. 18 times 3 is 54. 18 times 4 is 72. Now try with 24. I stopped there because I know 72 is the answer. 24 times 1 is 24. 24 times 2 is 48. Times 3 is 70. The moment you get the first overlap, there is your LCD. Okay, that's one way to find it. The downside of this is that it takes a lot of work writing things out, and it doesn't work so well when you have complicated problems that have M's and subtractions, etc.
I don't like M's.
All right, so I'll show you an alternate way, which is called the ladder method. Ladder method is simply this. You take the 2 numbers that you're dealing with, and you put them side by side and kind of have a division bar upside down, which may remind you of synthetic division. Okay, now what you're going to do is you're going to pull out factors on the outside. You're going to pull out factors and divide. Now clearly you see here that between 18 and 24, you can pull out a large factor, 6, but I'm going to show small ones just to show you the algorithm. So I'm going to pull out a factor of 2, divide by 2, and I get 9 here and 12 here. Now I'm going to repeat that process. What other factor can I pull out? Oh, look, I can pull out a 3, which means divide by 3, I get 3 here, and I get 4 here. Now, since down here there are no more common factors, I'm actually done getting it as far as I can. The benefit of this method now is the LCM is right here. 2 times 3 times 3 times 4. In other words, the L shape that's around it is your LCD. 2 times 3 times 3 times 4. And that would be 72. Why is this a helpful method? Because this actually not only shows me what the LCD is, it shows me how to get to the LCD. Watch this. If I take 24 and I multiply it by this diagonal 3, I get 72. If I take this 18 and multiply by the diagonal 4, I get 72. So not only does it show me what the LCD is, the product of the L around here, but it also shows me how to get from 18 to 72, how to get from 24 to 72. All right, so this is called the ladder method, sometimes called the Chinese ladder method or Asian method. So now I'm going to take the 18 and I'm going to multiply it by 4 here. And I'm going to multiply both this fraction by 4 here and 4 here. Same thing here. The 24 needs to be multiplied by 3, so that's going to multiply by 3, as is its numerator. So let me go ahead and rewrite that over here. I'm going to multiply this one by 4 and this one by 4. Because remember, 4 divided by 4 is 1. Multiply this one by 3 and this one by 3. Notice I'm not multiplying by 3 because the top was 3. I'm multiplying by 3 to get this to 72, which is coincidence that that's a 3. All right, so now start multiplying out. 7 times 4 is 28 over 72. 3 times 3 is 9 over 72. And now we use our rules from yesterday. When you have a common denominator, all you do is combine your like terms in the numerator. So in this case here, I get 37 over 72. Since this does not simplify any further, that is my answer. Now let's look at number 2. If I were to go a little bit faster, I want to find a common multiple. Some of you quickly see what it is. But I can do 12 and 16. I can pull out a 4 to get 3 and 4. Now I just do 16 times 3 and 12 times 4. So I take the 5 and I'm going to multiply it by 4. The 12 multiplied by 4.
Wait, I'm confused how this works.
And now I'm going to multiply the 16 by 3 down below, which means I multiply the 3 by 3 in the numerator. Again, that's just a coincidence that I'm multiplying by 3. I found that 3 from here, right there. Now I can rewrite things to get 20. Notice the magic that I can do right here. Write it all over one denominator. I don't have to keep it separated. We know it's going to come together anyhow. So I'm going to skip that step and combine. All right, and now I see here that it doesn't go any further. There are no common factors between 29 and 48, and I'm done. Okay, so let's refresh. One thing that we're trying to do is we're trying to see what this denominator has that this one doesn't, and vice versa. And when we discover what is the missing component, that is the missing factors, we're going to share them over here. So quickly speaking, what does this blue one have that the red one doesn't? It has an extra x. So let's share that x over here. Now, does the red x have something that the x squared doesn't have? Nope, so he doesn't have to share right now. All right, so notice I didn't have to use a table. I didn't have to do counting. I didn't have to do the ladder method. I just thought about it real quick. What factor does this have that this one doesn't? Okay, so, and then I began to share it. Now, I'm going to ignore the cells right now and just show the work across. So although it says LCD there, I'm just going to ignore that. So 2 times x is x. And then, of course, this stays as is. I don't need to change that at all because it's not multiplying by anything. So I just write it, and it's all over the x squared. Now we can combine what can be combined, LCD, combine like terms. Notice that 2x minus 2x is 0, so that drops out. I'm left with a 1 in the numerator and an x squared in the denominator. So when we think about sharing, this puppy right here has a 3 to share. So I'm going to share that top bottom. Remember that the top is a group, so I'm putting parentheses around it. Now what about the m squared? What does this have that my 3m doesn't have? It has an extra m. So multiply by m top and bottom. Because m divided by m is 1, so it only changes the form, not the value. Okay, so notice what the LCD down below is. 3 times m, or 3m squared. Those are the same thing. So I'm going to bring it all together over one common denominator. And this here is 2m. And when I distribute the 3 here, I'm going to get plus 9 minus 6m.
Can you combine the 2m and the negative 6m?
Good. And now we combine like terms. So the 2m minus the 6m is negative 4m. The 9 stays as is. And 3m squared. The last step is to always check, is there anything else to simplify? And how do we simplify fractions? We always have to factor. So notice that between the negative 4 and the positive 9, there's no common factor. This guy doesn't have an m out here, so I'm not going to factor anything out. And nothing reduces in the numerator and denominator. So here is my answer.
What is math?
Why?
Baby, don't hurt.
So on number 5 here, I'm going to factor the denominator
Can we look at it as
to find anything that's missing. See what the m plus 3 doesn't have. Something to share. What can we share? So I'm going to pull out a 3. And now notice here. I'm not even going to bother rewriting all of it. I'm just looking at that first one. The red one factors out of 3. So now let's look at these factors here, and this one over here in the blue. What does the red have that the blue doesn't? An extra 3. So if you multiply this whole thing by 3 and this one by 3, we now equalize it. Notice that this blue, m plus 3, doesn't have to share because the red one already has an m plus 3 as a factor. So now I can rewrite, and I'll skip all the way to one common denominator, and I'm going to keep that factored. Why? Because at the end I'm going to see if there's anything to simplify. The numerator, the 11, stays as is. I'm subtracting now, and 3 times 3 is 9. And now I simplify to get 2 over 3 times m plus 3. Notice the 2 and the 3 cannot reduce. This 2 and this 3 don't reduce. There's no m plus 3 up there to reduce. So there's my final answer. So when we have denominators that have common factors, notice we're just finding the factors that the other doesn't have and we're sharing it. Sometimes though, take for example number 7, they don't have common factors to factor anything out. So for example, this x plus 1 and this x minus 3 have no common factors between them. So all we do is share with each other the entire thing. So notice this whole x minus 3 just goes top bottom to the other fraction. And this x plus 1 goes top bottom on the other fraction. So when there's no common factor, all you have to do is exchange denominators with the other fraction. So that one goes over here, and this one goes over here. Again, you do not need to multiply out the denominator. Do not spend your time doing FOIL or double distribution. Just write it as it is. Up here, I'm going to distribute and distribute the negative 1 so that in the end I can combine like terms. All right, so let me walk through this first one here. The 5 is going to distribute there to get 5x minus 15. And pay very close attention here. The negative 1 distributes to both of those terms. So it's minus x minus 1. I'm going to write that all over one denominator, and I'm going to leave that denominator factored. No sense in doing extra work. At the end, I have to factor anyways to see if something simplifies. Now I begin to combine like terms. In the numerator, I get 4x because 5x minus 1x is 4x. And now the negative 15 minus 1 is negative 16 all over the common denominator. Not quite done. I do want to see if anything simplifies. So I'm going to factor the numerator like so. And the bottom denominator is still factored. And since nothing reduces, no x minus 4s down here, no 4s over here to reduce, this is my final result.